Hello everyone, Varna here, and today's topic for the class is vitamin K. The letter K is due to the German word coagulation, and that's how the vitamin got the letter K from the word coagulation, because this is the vitamin which helps in coagulation of blood. You know what is coagulation? The blood is getting coagulated in order to prevent the bleeding. If there is an injury or a wound, there will be bleeding from the capillaries, and the blood will be oozing out. So in order to prevent that, the blood along with the coagulation factors, it gets coagulated and the bleeding is being stopped. So this is the vitamin which helps in coagulation, blood coagulation. Let's see the food sources. The food sources of vitamin K includes cabbage, cauliflower, spinach and other green leafy vegetables, as well as certain cereals. Then metabolism, it is provided in the diet or it is also synthesized by certain intestinal bacteria. And the absorption is along with the fats, and since it is with the fats, it depends upon the bile salts, which helps in the fat absorption. And vitamin K is transported in blood along with the lipoprotein LDL, and it is stored in liver, and it is stored in lesser extent in other tissues. So it is mainly found in liver. One of the main function, it is the clotting, the blood coagulation. It helps. Vitamin K dependent clotting factors are there, that is clotting factor 2, 7, 9 and 10. 2, 7, 9 and 10, these are the vitamin K dependent clotting factors. 2 plus 7 equal to 9, then 10. Okay, so these are the vitamin K dependent clotting factors. So during the synthesis of these clotting factors, they, in the post translation modification step, that is, they should be in the mature form or in the active form. So for that step, during the synthesis, vitamin K is required. During the maturation of these clotting factors, we require vitamin K. Vitamin K is necessary for the post-translation modification of certain blood clotting factors. The clotting factors like 2, 7, 9 and 10. When they are synthesized in the final state, that is during the post-translation modifications, once they're proteins, these clotting factors are proteins. So when these proteins are being synthesized during the last state, that is post-translation modification, where they are getting converted into mature proteins or mature clotting factors, in the last state, we require vitamin K. So if there is vitamin K deficiency, these clotting factors will be in the immature form or in the inactive form, and they won't be functional. So for these clotting factors to be functional, they require vitamin K for their post translation modification. So that is occurring with the help of vitamin K. It helps in the carboxylation. So this is why vitamin K is helping in blood coagulation. Blood coagulation through the maturation of clotting factors of 2, 7, 9 and 10. Next function is in the role in synthesis of bone protein. Bone protein osteocalcin. Osteocalcin, that is the bone protein synthesized by osteoblast. Then this osteocalcin is binds tightly to the hydroxy peptide crystals of the bone and is required gamma carboxylation. This gamma carboxylation is with the help of vitamin K. So it is helping the bones as well, for the synthesis of bone proteins. So this is the mechanism of vitamin K helping the bones to retain calcium. So these are the two functions. One is clotting factor, then another one is synthesis of bone protein. Next, let's see what is vitamin K cycle. Cycle of events following gamma carboxylation reaction, whereby reduced vitamin K is regenerated. It is mainly occurring in endoplasmic reticulum of the liver, and vitamin K dependent carboxylase reaction occurs within endoplasmic reticulum of many of the tissues, and they require molecular oxygen, carbon dioxide, and hydroquinone, which is the reduced form of vitamin K. Next is the RDA. RDA in males it is given as 45 to 80 microgram per day, and in females it is 45 to 65 microgram per day. In children it is 15 to 30 microgram, whereas in infants it is 5 to 10 micrograms. Next we'll move on to the deficiency. In normal adults, the deficiency is very rare, and it occurs in malabsorption of lipids because it is transported with the help of lipoproteins. So you can see the deficiency in obstructive jaundice and pancreatitis due to the malabsorption of lipids. The next cases are due to the prolonged antibiotic therapy or gastrointestinal infections with diarrhea. This may lead to the intestinal bacteria not producing enough vitamin K. One of the major sources of vitamin K is intestinal bacteria as well as. So if they are destroyed due to the antibiotic therapy or due to infections, that also can lead to deficiency of vitamin K. Then due to vitamin K deficiency in newborns, it can lead to hemorrhagic diseases of newborns, HDN. It might be due to sterile intestine or due to the dietary insufficiency of vitamin K, because the breast milk is deficient of vitamin K. Breast milk cannot fully provide the daily requirements. Then next cause is due to no hepatic storage of vitamin K in newborns. This is prevented by the routine administration of vitamin K injections in all newborn babies as prophylaxis. In children and in adults, this vitamin K deficiency can lead to spontaneous bleeding. Then everything related to the bleeding, because vitamin K is not available for the clotting factors to get mature. So clotting factor is not active and coagulation doesn't occur, and this can easily lead to bleeding. Then bruising tendency, then enzymatic patches, that is everything is related to the bleeding. Even a small or mild pressure over the skin or the capillaries can lead to the leakage of the capillaries due to bleeding, and there will be color changes and bleeding. Then post-traumatic bleeding, profuse bleeding, then hematomas, etc. Bleeding gums, etc. will be seen if there is vitamin K deficiency in adults and in children. The biochemical parameters of vitamin K deficiency. Vitamin K deficiency can lead to prolongation of prothrombin time and delayed clotting time. This may be the two reasons may be due to the defective synthesis of prothrombin, which is not related to vitamin K. This is defective synthesis of prothrombin, and other main causes due to vitamin K deficiency. So this is the reason why if a patient is coming with severe bleeding, we are administrating vitamin K to the patient as injections. So if there is any vitamin K deficiency leading to the immaturation of clotting factor, that can be healed. So if a bleeding person is administered with vitamin K, the clotting factors can be matured by the available vitamin K and can prevent bleeding. It is necessary to measure prothrombin time before and after administration of vitamin K. This is in order to understand if there is any defect in prothrombin time. Even after before and after administration of vitamin K, we need to check the prothrombin time in order to see if there is a defective prothrombin synthesis. If the bleeding is due to defective synthesis of prothrombin. Then hypervitaminosis, administration of large quantities of may result in toxicity, hemolysis, hyperbilirubinemia, etc. will be seen. Then vitamin K antagonist, which is preventing the functions of vitamin K. Those are warfarin and decumerol. They completely inhibits the gamma carboxylation due to structural similarity to vitamin K. They are inactivating the vitamin K due to the structural similarity with vitamin K. They are structurally, this warfarin and decumerol, these drugs are vitamin K antagonist. They are inhibiting the gamma carboxylation caused by vitamin K as they are structurally similar to vitamin K. Thank you.